Let us study about alkali and alkaline earth metals. Okay, you know the periodic table. This periodic table is divided into four blocks: S block, P block, D block, and F block, isn't it? You know where this S block is located. Where is this S block is located in the periodic table? This S block is located in the first and the second group in the modern periodic table. Okay, this first and second group elements or these S block elements are otherwise called as alkali and alkaline earth metals. Alkali and alkaline earth metals. Today let us study the first block element, namely alkali metals in detail. Okay, you look at this video. The first block and the second block of this periodic table is called as what? S block element. Why these block elements are called S block? Because they have S orbital as their outermost orbital. S orbital as their outermost orbital. Let us study this group 1 in detail. This group 1 is comprises of lithium, sodium, potassium, rubidium, cesium and francium. Okay, there are 7 elements are found in the first group. These 7 elements are called as what? S block elements or alkali metals. The other name of this 1s group is called as S block or alkali metals. Okay. Let us study the general characteristics of alkali metal. The first one is alkali metals are highly reactive. Okay, if you look at the reactivity of these alkali metals, they are highly reactive. You can see that these alkali metals, okay, they found in nature as a compound. Okay, I'm repeating, the alkali first characteristic of alkali metals are highly reactive. These alkali metals are highly reactive. Okay, when you take this alkali metal from the earth crust, it is not at all found in the native state. That means potassium is not at all found as potassium. Okay, it is found in the earth as a compound. That indicates the reactivity of this potassium metal. Okay, so they are highly reactive. Next, metals are found in compound. Okay, next, rubidium and cesium. Okay, the elements of the first block. Okay, this rubidium and cesium found in the lower part of this first block. See, this rubidium and cesium is found in minute quantities. Okay, only less amount of rubidium and cesium are found on the earth crust. Okay, next, the only radioactive alkali metal is francium. Francium is a radioactive metal. Okay, it is highly radioactive. Francium is highly radioactive. If you see, one of the isotope of francium has a longest half-life, that is 21 minutes. Okay, the isotope of francium, that is radioactive in nature, francium has, okay, the isotope of francium has a longest half-life period. The half-life period of this francium is 21 minutes. Okay, if you see the alkali metals like lithium, The lithium is the most abundant alkali metal, and francium is the radioactive alkali metal. Francium is a radioactive alkali metal. Next, we shall study about the common oxidation state of these alkali metals. See, these alkali metals are highly electropositive in nature. All these alkali metals are highly electropositive in nature. You know what is electropositivity? It has a tendency to lose its valence electron. It can easily lose one of its valence electron which is found in the outermost orbital, and it can acquire a +1 oxidation state. So all these alkali metals can form +1 oxidation state. Let us see this electronic configuration. So electronic configuration of lithium is 1s2 2s1. Okay, the outermost orbital is 2s1. Let's see the electronic configuration of sodium: 1s2 2s2 2p6 and 3s1. Okay, next potassium's electronic configuration is 1s2 2s2 2p6 3s2 3p6 and 4s1. In all these, you could see the S1 as the outermost orbital. See, S1 is the outermost orbital. That is why this group is also called as 1s block element. What is the other name of alkali metal? 1s block element. Why it is called so? Because it has only one s electron in its outermost valence shell. That's why it is called as a 1s block metal. And also because of the similar electronic configuration, the alkali metals have similar physical and chemical property. Why these alkali metals have similar and chemical properties? Because of the similar electronic configuration. Okay, next, regarding this atomic and ionic radii. Okay, if you see the periodic table, each and every period, the alkali metals place the first position in each and every period. So for second period, the alkali metal lithium is placed first. Okay, in the second period, the alkali metal lithium is placed first. For third period, the alkali metal sodium is placed first. For fourth period, the alkali metal potassium is placed first. For fifth period, the alkali metal rubidium is placed first. For sixth period, the alkali metal cesium is placed first. For seventh period, the alkali metal francium is placed first. Okay, regarding this atomic and ionic radii, all these alkali metals occupies the first place in the each and every period. Okay, so these alkali metals have the largest atomic and ionic radii. Alkali metal have the largest atomic and ionic radii in their periods. Okay, if you look at this, on moving down the group, okay, if you come down the group, okay, look at this. I'm repeating this again. Atomic and ionic radii. See, these alkali metals placed in the first position in each and every periods. So, in each and every periods, the alkali metals have the largest atomic and ionic radii in each and every periods. Okay, if you look at this groups, on moving down the group, there is a increase in the number of shells. Okay, as we move from top to bottom in a group, there is a increase in number of the shells, and therefore the atomic and ionic radii is increases. The third one is the monovalent ions are smaller than the respective parent atom. If you see or if you compare the atom with its monovalent ions, okay, the size of the atom is bigger, but the monovalent ions are smaller. Okay. See the electronic configuration. Okay, for sodium configuration is given here. The third orbital, there is only one s electron that is revolving around the nucleus. Okay, so this sodium ion cannot hold this third electron. So if we give little energy, okay, if you give little energy, what happens? This third electron can be removed and it forms a positive ion. Now this is not said, it is not termed as a atom, it is said to be a positive ion, that is Na plus ion. So now the sodium attains a noble gas electronic configuration, that is the stable electronic configuration. See the periodic properties of this atomic radii. Okay, in the first group, lithium, look at the size of lithium atom. It is smaller than sodium, than potassium, rubidium, cesium. As we move down the group, the size of the atom increases because of the addition of extra valence shell. Okay, extra shells. Okay, for each and every period, one cell is increased. Because of that increase in the shell, the atom sizes increases. Okay, if you compare the size of an atom and and its ion, okay, if you compare the size of an atom and ion, okay. See, look at this electronic configuration of this first group element. All these elements possess only one electron in its valence shell. In this diagram also, there is a 3s electron, only one 3s electron is revolving around this atom. So it cannot hold this electron. That's why little energy is supplied. So the electron is lost. Now the atom becomes ion. The size of an atom is greater while the ion is smaller, and this atom, the ion acquires a stable noble gas electronic configuration. Okay, that is +1. Okay, now regarding the atomic size, see, as we go down the group, the atomic size is gradually increases because of the number of shells increases. For first group, there is one shell. Second group, there are 2 shells, 3 shells, 4 shells. Okay, because of the addition of extra shells, the size of an atom increases. Here, for potassium atom, the size is increased. Okay, the size is greater for potassium atom, but if the potassium loses one electron, it becomes plus ion, K plus ion, the size is decreases. Okay, when we compare the size of an atom and ion, monovalent ion, the size is decreased to that of its respective atom. Okay, so as we go down, the size of an atom increases. In the group, okay, in periods, okay, from left to right, the size of an atom decreases. Okay, here the first element is bigger in size, but as we move from left to right, the size is decreases. Okay, this is regarding the atomic size and ionic size. Some of the physical properties are listed in the table. Atomic radius, okay, for lithium, the first group elements, the atomic radius is given with respect to angstrom. For lithium 1.52, the atomic radius is 1.52. For sodium, the atomic radius is 1.86. Potassium, the atomic radius is 2.27. Rubidium, the atomic size is 2.48. Cesium, the atomic size is 2.65. Likewise, ionic radius is given. Melting point, boiling point, first ionization enthalpy, electronegativity, density, standard electric potential, and hydration enthalpy is also given. Okay, the next term is ionization enthalpy. Okay, what is ionization enthalpy? What is ionization enthalpy? The amount of energy which is supplied to an atom to lose one electron or to remove one electron. The amount of energy is supplied to an atom to remove one electron is called as what? Ionization enthalpy. Okay. This alkali metals generally requires lowest ionization enthalpy. That means if you give little amount of energy to this alkali metals, okay, they can easily we can easily remove the electron. Okay, so the alkali metals have lowest ionization enthalpy. If you look down, if you okay, as we go down the group, the ionization enthalpy decreases. Okay, from top to bottom, the ionization enthalpy decreases due to increase in size. As the number of shells are added, okay, as we move down the group, the size of an atom increases. So the nucleus cannot hold all the electron which is found in the outermost shell. That's why we can supply little energy to that atom and we can convert the atom into ion. Okay, that's why as we move down the group, the ionization energy is decreases. Okay, next the second ionization enthalpies are very high. Okay, the first ionization energy is very low. What do you mean by second ionization energy? That is, already the ions are formed by loss of electron, right? These ions, okay, from these ions, if you remove an electron, it is impossible or it is very tedious process. We have to spend lot of energy to remove one electron from the ion with the noble gas configuration. Okay, that's why the second ionization enthalpy increases. Okay. So, ionization energy is the energy required to remove the electron. You could see for sodium there is only one electron is revolving around the nucleus. Okay, in the third orbital there is only one electron is revolving around the nucleus. So, little energy supplied to remove this. Okay. So, look at this ionization enthalpy decreases from top to bottom, and also the ionization energy of this lithium, sodium, potassium, rubidium, cesium with respect to that of their group is very their period is okay, with respect to that of their period is less. Okay, so alkali metals have low ionization enthalpy. Next one is hydration enthalpy. What do you mean by hydration enthalpy? Okay, when a compound of alkali metal is dissolved in water, okay, the energy required to dissociate the ions in the water solvent is called as what? Hydration enthalpy. Okay, here this lithium salts are more soluble than that of the other metals. Okay, lithium chloride, one of the salt of lithium. Okay, it can readily soluble. Okay, that is 12 times more soluble than sodium chloride. Likewise, potassium, rubidium and cesium salts have the solubility is 10 to the power minus 3 times of that lithium chloride. Why lithium exhibit this um, readily soluble tendency? Because the size of lithium is very small. Okay, that's why it can readily dissolve in water. The size of lithium is small. Okay, now what is enthalpy of hydration? Here the energy required to dissociate the molecule, the amount of energy released or absorbed when 1 mole of an ion are dissolved in a large amount of water. I am repeating again. What is hydration energy? So what is hydration energy? The molecule is dissociated into its ion in water, isn't it? The amount of energy released or absorbed when 1 mole of an ion is dissolved in a large amount of water is called as what? Enthalpy of solvation or hydration enthalpy. As we move down the group, the enthalpy of hydration or hydration energy decreases from top to bottom. Okay, okay, lithium chloride dihydrate, okay, has more hydration energy. That means it can easily soluble in water because of its smaller ions. Okay, and also here the enthalpy of hydration is given. Go through this. For lithium minus 519, for Na plus ion minus 406, K plus ion minus 322, rubidium plus ion minus 293 kilojoules per mole, cesium plus ion minus 246. That means the negative value means the value indicates, the negative value indicates less amount of hydration enthalpy. Okay. Electronegativity. What is electronegativity? The tendency to attract electron is called what? Electronegativity. So already this alkali metals. Okay, alkali metals have only one electron in its outermost orbital. Okay, so it cannot gain 7 more electron to attain a octet complex. Electronegativity. What do you mean by electronegativity? I am repeating this. Electronegativity, the tendency of an element to gain electron is called as what? Electronegativity. The alkali metals have smaller value for electronegativity. Okay, that means alkali என்ன செய்யாது, அந்த எலக்ட்ரானை கெயின் பண்ணக்கூடிய அது டெண்டன்சி அதுக்கு இருக்கவே இருக்காது. இட் ஹாஸ் அ டெண்டன்சி டு லூஸ் எலக்ட்ரான் ஒன்லி. ஓகே, ஏன்னா இட் ஹாஸ் ஒன்லி ஒன் எலக்ட்ரான் இன் இட்ஸ் அவுட்டர் மோஸ்ட் ஆர்பிட்டல். அதனால் அது என்ன செய்யும், அது ஈஸியாக ஒரு எலக்ட்ரானை கொடுத்து அது ஒரு பாசிட்டிவ் கேட்டையான மாறுதான் ட்ரை பண்ணும். ஓகே, when they react with other elements they usually produce ionic compounds. Okay, the electronegativity இல்லாததுனால இது என்ன செய்யுது, வேறு electronegative எலிமெண்ட்ஸோட ரியாக்ட் பண்ணி அயானிக் காம்பவுண்ட்ஸை கொடுக்கும். ஸ்பெஷலி this alkali metals have a tendency to react with halogens and oxygen. Okay, halogens especially they have the reactivity towards halogen to form ionic halides. Next, flame color and spectra. So it is a characteristic test. Flame test is a characteristic test to identify the cation which is found in the salt. Okay, so the flame test அப்படின்னா என்னன்னா, the salt alkali metals இருக்கக்கூடிய சால்ட்டை என்ன செய்வாங்க, ஒரு small amount of salt is dissolved in hydrochloric acid and cobalt nitrate solution. அது a part of this paste, ஒரு paste மாதிரி பண்ணிடுவாங்க. Okay, a part of this paste is introduced into the non-luminous part of the Bunsen flame. Okay, so as you impart this, as you introduce this paste into the non-luminous part of the flame, what happens? It gives a color, characteristic color. It gives a characteristic color that indicates what type of ion is found in the given salt. உனக்கு கையில் தந்திருக்கக்கூடிய சால்ட்டில் என்ன மாதிரியான alkali metals இருக்குது அப்படின்னு சொல்லி அந்த கலரை வச்சு ஐடென்டிஃபை பண்ணலாம். இதுதான் என்னது ஃப்ளேம் டெஸ்ட்டு. ஓகே, ஏன் இந்த கலர் ஃபார்மேஷன் நடக்குது அப்படின்னா, when you heat that salt, no, that time what happens, the electron which is found in the outermost orbital gains certain amount of heat energy. அது கொஞ்சம் heat energy-யை கெயின் பண்ணிட்டு இது என்ன செய்யுது, it excited to its higher energy level. மேலே it jumps up into its higher energy level. Okay, as it jumps up to its higher energy level, that can be visible. ஓகே, அந்த எலக்ட்ரான் அப்படி ஜம்ப் பண்ணி போகும்போது அந்த விசிபிள் ரீஜியன் விஜிஆர் இருக்குதுல்ல, அதில் உள்ள அந்த வேவ் லென்த்துக்கு கரஸ்பாண்டிங்காக இருக்கும்போது we can see the color of the flame. Okay, now a salt is taken, it is made into paste and it is introduced into the non-luminous part of the flame. It gives a specific color. This is called flame test. See, the electron gains energy and it is jumped up to its excited state. Okay, so it gives a respective color. Okay, now this is called flame test. Lithium gives candy apple red color or cherry red color flame, whereas sodium gives yellow color flame and potassium gives lilac or violet color flame with the flame test. Okay, lithium gives crimson red, sodium gives yellow color, potassium gives lilac or violet color, rubidium is reddish violet in color, cesium gives blue color as it is introduced into the non-luminous part of the Bunsen flame. Okay, next, distinct behavior of lithium. If you look at this lithium is the first element of the 1s block group, isn't it? The 1s block groupல இருக்கக்கூடிய இந்த லிதியத்துக்கு ஒரு ஸ்பெஷல் பிஹேவியர் இருக்குது. Why this lithium is behaving differently than that of other elements? The first point is it has a exceptionally small size. Lithium has a exceptionally small size. அதனால அது lithium என்ன செய்யுது, டிஃப்ரெண்ட்டாக பிஹேவ் பண்ணுது. நெக்ஸ்ட் ஒன் இஸ் lithium has high polarizing power. ஓகே, இந்த போலரைசிங் பவர் அப்படின்னா அது வந்து என்ன செய்யுது, அது பாசிட்டிவ் சார்ஜை தன்னோட இட் பொசஸ் அ பாசிட்டிவ் சார்ஜ், isn't it? அந்த போலரைசிங் பவரு அதிகமாக இருக்கிறதுனால லித்தியம் டிஃப்ரெண்ட்டாக பிஹேவ் பண்ணுது. தென் ஹை ஹைட்ரேஷன் எனர்ஜி அண்டு நான் அவைலபிலிட்டி ஆஃப் டி ஆர்பிட்டல். ஓகே, ஒய் த lithium is behaving differently than that of other elements? Because of small size, high polarizing power, high hydration energy and non-availability of d orbital. And also you could see some of the difference in properties of lithium with other elements. Okay, the first one is when you look at this lithium, it is hard and it is high melting and boiling point. லித்தியத்துக்கு ஹார்டாக இருக்கும், இதோட மெல்ட்டிங் பாயிலிங் பாயிண்ட் வந்து அதிகமாக இருக்கும். whereas the other elements of this family are soft and lower melting and boiling point. They have lower melting point and boiling point. If you look at this lithium, okay, it is least reactive. Lithium is least reactive. For example, with the oxygen, it forms normal oxides, peroxide. okay, but it don't give superoxide. If it forms superoxide also, it is unstable, okay, whereas the other elements are more reactive towards oxygen. Other elements can form peroxide, superoxide, normal oxide, okay. Next, reaction with the nitrogen, okay, lithium nitrogen oda react panni nitride, lithium nitride கொடுக்குது. Whereas the other elements of this family, they don't react with the nitrogen at all. Next, reaction with the bromine, lithium slowly, okay, lithium react bromine slowly, lithium react with bromine slowly, whereas the other elements of the family reacts violently. Next one is lithium reacts with the carbon to give lithium carbide. It is a ionic compound, okay, lithium reacts with the carbon to give lithium carbide. It is a ionic compound, whereas the other members of this family, they don't react with the carbon directly, but they can react with the compounds of carbon like acetylene, ethylene, etc. to give their respective carbides and eliminates hydrogen, okay. Next, lithium nitrate decomposes to give an oxide, whereas all the other elements are whereas the other members of this nitrate gives nitrides, okay. lithium nitrate என்ன செய்யும், ஆக்சைடை கொடுக்கும், whereas the other members oda nitrates வந்து nitrides கொடுக்கும் decompose பண்ணி, okay. Let us study the difference in behavior of lithium and magnesium, okay. Diagonal relationship. See, this lithium belongs to first group and magnesium belongs to the second group. There is a relationship, there is a similarities in behavior between the first group lithium as well as second group magnesium, okay. Let us study this diagonal relationship of lithium and magnesium in detail. The first one is lithium is denser and and harder. The first property of lithium is denser and harder. Next one is lithium has higher melting point and boiling point than other alkali metals. The third point is lithium is least reactive, yet it is best reducing agent in the family, okay. Lithium chloride is a dihydrate. Whereas the other halides are anhydrides, okay. Other metallic hydrides are other metallic chlorides are anhydride. Sodium chloride, potassium chloride, rubidium chloride, cesium chloride, all are anhydrous. That means there is no water at all, okay. But only lithium chloride has 2 molecules of water, okay. These are some of the anomalous properties of lithium with their other members, okay. Lithium can form bicarbonate, lithium bicarbonate, okay. Lithium doesn't react with the lithium doesn't react with the ethylene, whereas sodium react with the acetylene, okay. Repeating once again, lithium do not react with the acetylene, okay, whereas repeating once again, lithium do not react with the ethylene, okay, whereas sodium reacts with the ethylene to form sodium ethanide, CH2Na, okay. Lithium nitrate, look at this, lithium nitrate, on heating it decomposes to give lithium oxide plus nitrogen dioxide. Okay, whereas the other elements, nitrates, okay, for example, sodium nitrate gives sodium nitrite. NO3, NaNO3 is nitrate, NaNO2 is nitrite. Okay, lithium nitrate is decomposes to give what? Lithium oxide and nitrogen dioxide, but the other members nitrate gives nitrite. Other members nitrate gives nitrite. Okay. What are the similarities between lithium and magnesium? Both lithium and magnesium are harder than other elements in the respective group. First point already we studied. Then lithium and magnesium react slowly with water. Their oxides and hydroxides are much less soluble, and their hydroxides decomposes on heating. Both the lithium and magnesium forms nitrates. Okay, both the lithium and magnesium reacts with nitrogen to give their respective nitrites with. Okay, the fourth point is they do not give any superoxide and form only oxides. They do not form superoxide. Lithium and magnesium, they do not form superoxides, but they form only oxides. Okay, the carbonates of lithium and magnesium decomposes on heating. Lithium carbonate, magnesium carbonate decomposes on heating to give their carbonates. The carbonates of lithium and magnesium decomposes on heating to give their oxides and carbon dioxide. Next, lithium and magnesium do not form bicarbonate. அது என்ன செய்யாது? Bicarbonate form பண்ணாது. Okay, both lithium chloride and magnesium chloride are soluble in ethanol and deliquescent. Okay, what do you mean by that? Ethanol இது என்ன லித்தியம் குளோரைடும் மெக்னீஷியம் குளோரைடும் எத்தனாலில் டிசால்வ் ஆகும். ஆனால் இட் இஸ் டெலிக்வசன்ட். வாட் யூ மீன் பை திஸ் டெலிக்வசன்ட்? இட் கேன் அப்சார்ப்ஸ் த அட்மாஸ்பியரிக் மாய்ஸ்சர். ஓகே, அட்மாஸ்பியரில் இருக்கக்கூடிய மாய்ஸ்சர் அப்சார்ப் பண்ணி அது என்ன ஆயிரும்? ஒரு aqueous சொல்யூஷனாக ஃபார்ம் பண்ணும். And also they can crystallizes to form aqueous solution as hydrides. Okay, lithium chloride with 2 molecules of water, magnesium chloride with 8 molecules of water. So the diagonal relationship of lithium and magnesium already we learnt. Okay, reaction with nitrogen. Both the elements reacts with nitrogen to form their nitrides. React slowly with water. They do not form superoxide. Okay, their carbonates decompose on heating to form carbon dioxide and their oxides. Okay, both forms chlorides that form hydrates and soluble in water. Okay, they form chlorides. Both the chlorides are soluble in water. Okay, these are the similarities of lithium and magnesium. Okay, what are the diagonal relationship? Okay, why lithium and magnesium exhibit similarities in their properties? Because of the similarities in size. Okay, why lithium and magnesium exhibit similarities in size? Repeating, diagonal relationship. Okay, even though repeating, diagonal relationship, even though lithium belongs to first group and magnesium belongs to second group, there is a similarities in properties of this lithium and magnesium. Okay, why this lithium and magnesium exhibits similarities in properties? Because of some reasons. 2 reasons are given here. Lithium, the ionic size of lithium and magnesium are approximately equal. The first point is the ionic size of lithium and magnesium are approximately equal. That is, the radius of lithium plus ion is 0.76 angstrom and the radius of magnesium 2 plus ion is 0.72 angstrom. Then their electronegativity values are comparable. Both the atoms electronegativity is comparable. For lithium 1.0 and magnesium 1.2. Because of these two reasons, this lithium and magnesium are in diagonal relationship with each other. Okay, first one is the radius of lithium and the radius of magnesium ions are approximately similar, and also the electronegativity values of lithium and magnesium are comparable. Because of these two reasons, this lithium and magnesium exhibit a diagonal relationship. Then regarding chemical properties of alkali metals. First properties, these alkali metals exhibit a high chemical reactivity. Alkali metals exhibit high chemical reactivity. Okay, as we move down from top to bottom in the 1s block element, okay, the reactivity of alkali metal increases from lithium to cesium. Ionization energies increases, ionization energies decreases down the group. Reactivity increases but ionization energy decreases. Okay. Then all alkali metals are highly reactive towards more electronegative elements. The alkali metals are electronegative elements that belongs to P block. Okay, the electronegative elements like oxygen, halogens oda ரொம்ப ஈஸியாக ரொம்ப readily reactive towards this electronegative elements. Okay, then the most, so some of the properties are given here. They are most reactive metals. They do not found in pure state in nature, only in compound state. These elements must be stored under oil. They will even react with water and in air. Okay, that's why it is stored in oil. Then they are shiny, soft and silvery white metals can be cut with a table knife. Okay, we can cut with a table knife. The next one is they are the good conductors. Okay, they will form oxides on the outer safe. They will form oxides on outer surface. You could see the color is changed. Outer color, surface color is changed because of the oxide layer, formation of oxide layer. Next, reaction with oxygen. See, these alkali metals have a high tendency to react with oxygen and halogen, isn't it? So, when it is exposed to air, when alkali metals are exposed to air, it reacts violently and forms oxides on its surface. Okay. Next, lithium forms how many oxides? Monooxides. Sodium forms monooxides and peroxide. But other elements of this family can form simple oxide, peroxide and superoxide. All these oxides are basic in nature. Look at this chemical property. See how these elements are readily react with oxygen when it is exposed to air. Okay, it is violently reacting with the oxygen to form lithium monoxide. Lithium monoxide. Okay. Next, sodium reacts with oxygen to give sodium superoxide. What's the formula for sodium superoxide? Na2O2. But other elements can form sodium But other elements like potassium, rubidium, cesium can form their super oxides. Okay, look at this. This is lithium salt. This is sodium salt. Okay, lithium and sodium salt. When lithium oxide is dissolved in water, it gives lithium hydroxide. When lithium is dissolved in water, lithium oxide is when lithium oxide is dissolved in water, it gives lithium hydroxide. Now, potassium superoxide, the color is like this. Cesium superoxide is yellowish in color. The oxidation state of the oxide, lithium monoxide, the oxidation state of lithium is +1 and oxygen is -2. Sodium peroxide, here the oxidation state of sodium is +1, oxygen is -1. Rubidium superoxide, rubidium oxidation state is +1, oxygen's oxidation state is -half. Okay. Then reaction of alkalis with water. When lithium reacts with water, what happens? Lithium reacts with water to give lithium oxide only. Lithium hydroxide, sorry. When lithium oxide reacts with water, it gives lithium hydroxide, whereas lithium reacts with whereas the other alkali metals reacts with water to give sodium hydroxide. Sodium reacts with water to give sodium hydroxide and hydrogen gas is liberated. Likewise, reaction with the hydrogen gives their hydrides. Lithium reacts with the hydrogen to give lithium hydride. With the chlorides, okay, the metals can vigorously react with the chlorides, okay, chlorides to give their chloride. Okay, next, regarding the properties of these elements, they are crystalline solid, high melting points, soluble in water, large negative enthalpies of formation, and they are very stable compounds. How this sodium chloride is formed? Look at this. Okay, sodium has one electron in its outermost shell. This electron is transferred to chlorine to form a chloride ion. Here lithium gets oxidized as it loses one electron. Chlorine accepts one electron and it is reduced and it gains a negative valency -1. Whereas sodium gains a positive valency. Here sodium can act as a reducing agent, whereas chlorine can act as a oxidizing agent. Then reaction with the hydrogen. All alkali metals react with the hydrogen about 673 Kelvin except lithium. Okay, lithium requires 1073 Kelvin to form the hydride, whereas other members of this family requires 673 Kelvin to form hydrides. The reactivity of alkali metals with hydrogen decreases. Okay, if you look at this group from lithium to cesium, the reactivity towards hydrogen is decreases. Okay, in other words, the metallic hydride formation is decreases. The tendency to form the metallic hydride formation is decreases. Okay, then the ionic character of these hydrides increases from lithium to cesium. Okay, the hydrides behave as a Next reaction with the halogens. As I told you earlier, these alkali metals are highly reactive in nature. Alkali metals are highly reactive in nature. Alkali metals are highly reactive in nature. They can readily react with oxygen to form their respective halides. They are almost ionic crystals. The alkali halides are ionic crystals. Lithium iodide, okay, only one exception, that is lithium iodide is covalent in nature. Except lithium iodide, all other halides are ionic in nature. Why lithium iodide exhibit covalent character? Because of the smallest size. Okay, lithium is a smallest cation, and also lithium has high polarization power on iodide ion. That's why this lithium iodide exhibit covalent character. Next, reaction with the liquid ammonia. When these alkali metals are dissolved in liquid ammonia, you could see a deep blue color solution. These solutions conducting electricity. Okay, they are conductive in nature. Why they are conducting? Why the metals conducting electricity as they dissolve in ammonia? Because the conductivity of these metals in ammonia is equal to that of mercury. Look at the specific conductivity of mercury is 104 per ohm. And also, when sodium is in liquid ammonia, its specific conductivity is 0.5 into 104 per ohm. That's why when these alkali metals are dissolved in ammonia, they exhibit conductivity. So the reason behind is the alkali metal atom readily loses its valence electron as it is dissolved in ammonia solution. Okay, when these alkali metals are dissolved in ammonia, the outermost electron or the valence electron can go into solution, and they form a cation, and the electron are ammoniated. The cation, both the cation and electron are ammoniated to give ammoniated cation and ammoniated electron. Okay, எதனால இந்த ஆல்கலி மெட்டல்ஸை அமோனியாவில் டிசால்வ் பண்ணுனா அந்த கண்டக்டிவிட்டி வருது அப்படின்னா, ஃபர்ஸ்ட் ரீசன் இஸ் ஸ்பெசிஃபிக் கண்டக்டிவிட்டி of this alkali metal in ammonia is similar to that of mercury. Okay. The second reason is when this alkali metals are dissolved in ammonia, okay, the ammonia, the alkali metal loses its electron, valence electron இழந்து போயிடுது. அப்படி வேலன்ஸ் எலக்ட்ரானை லூஸ் பண்ணும்போது அந்த கேட்ரியானும் ஒரு எலக்ட்ரானும் ஃபார்ம் ஆகுது. ஸோ இந்த கேட்ரியான் கூடயும் அமோனியா சேர்ந்து ஒரு அமோனியேட்டட் கேட்ரியானாகவும், அந்த எலக்ட்ரான் கூடயும் அமோனியா சேர்ந்து ஒரு அமோனியேட்டட் எலக்ட்ரானாகவும் மாறுறதுனால தான் இந்த கண்டக்டிவிட்டி இருக்குது அப்படின்னு சொல்லி பார்க்குறோம். லுக் அட் திஸ் ரியாக்ஷன். When a metal is dissolved in X plus Y molecules of ammonia, it gives the metal cation with the ammonia, that is ammoniated cation, and also ammoniated electron. Okay, so the blue color நாம் பார்த்தோம், ஆல்கலி மெட்டல்ஸ் அம்மோனியாவில் டிசால்வ் பண்ணால் ப்ளூ கலர் ஆயிடுது. இந்த ப்ளூ கலர் ஃபார்ம் ஆகிறதுக்கு காரணம் என்னென்னா, இந்த அம்மோனியேட்டட் எலக்ட்ரான் என்ன செய்யுது, இட் அப்சார்ப்ஸ் த எனர்ஜி இன் த விசிபிள் ரீஜியன் ஆஃப் லைட். இந்த அம்மோனியேட்டட் எலக்ட்ரான் என்ன செய்யுது, அந்த எனர்ஜியை விசிபிள் ரீஜியன் ஆஃப் லைட்டில், அந்த ப்ளூ கலர் விசிபிள் ரீஜியன் ஆஃப் லைட்டில் இந்த என்ன செய்யுது, அந்த எனர்ஜி அப்சர்வ் பண்ணுறதுனால that blue color is imparted to the solution. அந்த சொல்யூஷன் என்ன ஆகுது, ப்ளூ கலராக இருக்குது. ஓகே, நெக்ஸ்ட்டு இந்த ப்ளூ கலர் சொல்யூஷன் அப்படியே நீங்கள் வச்சுருந்தீங்கன்னா ஆன் ஸ்டாண்டிங் தி சொல்யூஷன்ஸ் ஆர் paramagnetic. The blue color solution வந்து paramagnetic in nature. Okay, அது அப்படியே நீங்கள் on standing allow the solution on standing, slowly this blue color solution gives hydrogen. இந்த ஹைட்ரஜன் அமோனியாவிலேருந்து ஒரு ஹைட்ரஜனை, ஒரு ½ moles ஆஃப் ஹைட்ரஜனை லிபரேட் பண்ணிட்டு இந்த அமோனியா இந்த சொல்யூஷன் என்ன ஆயிடுது, ஒரு பிரான்ஸ் கலருக்கு ஃபார்ம் ஆயிடுது. அதனோட மேக்னெட்டிக் ப்ராப்பர்ட்டியை பார்த்தீங்கன்னா டயாமேக்னெட்டிக்காகவும் இருக்கும். ஓகே, அப்போ ரியாக்ஷன் வித் லிக்விட் அமோனியாவில் ஃபஸ்ட்டு பாயிண்ட் என்ன, when ammonia is dissolved in liquid ammonia it turns into blue color and also it is conductive in nature. ஓகே, இந்த கண்டக்டிவிட்டிக்கு காரணம் என்ன அப்படின்னா, இந்த அமோனியாவில் இந்த ஆல்கலி மெட்டலை டிசால்வ் பண்ணும்போது அதோட ஸ்பெசிஃபிக் கண்டக்டிவிட்டி இஸ் ஈக்குவல் டு த ஸ்பெசிஃபிக் கண்டக்டிவிட்டி ஆஃப் அ லிக்விட் மெட்டல் லைக் மெர்க்குரி. மெர்க்குரியோட ஸ்பெசிஃபிக் கண்டக்டிவிட்டிக்கு அப்ராக்சிமேட்லி ஈக்குவலாக இருக்கிறதுனால அந்த அமோனியாவில் அந்த ஆல்கலி மெட்டல்ஸ் இருக்கும்போது என்ன செய்யுது, எலக்ட்ரிசிட்டியை கண்டக்ட் பண்ணுது. அது மட்டும் இல்லை, when this metal is dissolved in ammonia, அமோனியாவில் அந்த மெட்டலை டிசால்வ் பண்ணும்போது அந்த மெட்டலில் இருக்கக்கூடிய ஒரே ஒரு வேலன்ஸ் எலக்ட்ரான் என்ன ஆயிடுது, தனியாக அந்த பிரிஞ்சு போயிடுது. ஓகே, பிரிஞ்சு போகிறது மட்டும் இல்லை, அந்த கேட்ரியானாவும் ஒரு எலக்ட்ரானாகவும் ஃபார்ம் ஆகுது. இந்த கேட்ரியான், அந்த மெட்டல் கேட்ரியானோடையும் அமோனியா சேர்ந்து ஒரு அமோனியேட்டட் கேட்ரியானாகவும், அந்த எலக்ட்ரானோடையும் அமோனியா சேர்ந்து அமோனியேட்டட் எலக்ட்ரானாக மாறுது. அப்போ இந்த அமோனியேட்டட் எலக்ட்ரான் என்ன செய்யுதுன்னா, இந்த எனர்ஜியை அப்சர்வ் பண்ணுது. எங்கள் விசிபிள் லைட்டில் ப்ளூ கலர்ஸ் ரீஜியனில் அது வந்து என்ன செய்யுது, அந்த எனர்ஜி அப்சர்வ் பண்ணுறதுனால அந்த ஆல்கலி மெட்டல் இன் அமோனியா இம்பார்ட்ஸ் அ ப்ளூ கலர் இன் சொல்யூஷன். ஓகே, அதோட மேக்னெட்டிக் ப்ராப்பர்ட்டியை பார்த்தீங்கன்னா தே ஆர் பேராமேக்னெட்டிக் அப்படின்னு சொல்லி பார்க்குறோம். பேராமேக்னெட்டிக் அப்படியே நம்ம நிறைய நேரம் அந்த சொல்யூஷனை வச்சுருந்தோம்னா தே லிபரேட் அ மாலிகுல் ஆஃப் ஹைட்ரஜன். ஒரு ½ molecules ஆஃப் ஹைட்ரஜனை லிபரேட் பண்ணிவிட்டு இந்த அமோனியா என்ன ஆயிடுது, அமைடாக மாறுது. MnH2 அப்படின்னா அமைடாக மாறிடுது. அண்ட் ஆல்சோ இந்த பேராமேக்னெட்டிக் என்னமாக மாறிடுது, டயாமேக்னெட்டிக்காக மாறிடுது. அதோட கலர் சேஞ்சை பார்க்கலாம். என்ன கலர் சேஞ்சா, ப்ரான்ஸ் கலரில் சேஞ்ச் ஆகிடுது. See this video. Okay, ammonia in the beaker, ammonia is taken. Okay, the metal is dropped into this beaker. Okay, look at this. So in the beaker ammonia is taken and the metal is dropped into the beaker. What happens, the solution turns into blue because of the ammoniated electron, and this solution is kept aside for few hours. What happens, the blue color, it is paramagnetic in nature. Okay, as this solution is kept aside for few hours, half molecule of hydrogen is liberated, and you could see the color change also. Okay, the color is changed into brown color. Okay, and the magnetic property is it is diamagnetic. Next, reaction with water. See, this alkali metals when reacts with water, it gives their respective hydroxides with the liberation of hydrogen. Okay, lithium plus water to give lithium hydroxide and hydrogen. Okay, and also they react with alcohol and alkynes which contain active hydrogen. Active hydrogen இருக்கக்கூடிய இந்த ஆல்கஹால்ஸ்லையும் alkynes these alkali metals react பண்ணுது. Listen here. When sodium reacts with ethyl alcohol gives sodium ethoxide. Okay, here the sodium reacts with the acetylene to give sodium acetylene. Okay, next. Sodium readily reacts with water. See, a drop of sodium is dropped down into water containing beaker. It is violently reacting with the water to give sodium hydroxide and hydrogen. If you test the sodium hydroxide, it is basic in nature. How will you test it? Add a drop of phenolphthalein to this sodium hydroxide. The solution turns into pink color. That indicates the solution is basic in nature. Next, reducing activity. See, alkali metals have a tendency to lose their valence electron and it is oxidized, and this elements enhance the reducing reaction. Okay, what is reduction? Gain of electron is reduction. Okay, in a chemical reaction, if electron is gained, means that reaction is said to be reduction. Here, as this alkali metals loses its valence electron, that becomes a source for reduction reaction. So these alkali metals are acting as a good reducing agents. Likewise, these alkali metals, okay, especially lithium, only reacts with the carbon directly to give lithium carbide. Other elements of this alkali family reacts with the compounds of carbon. Okay, here with the acetylene. Okay, the compounds of carbon. Acetylene to give acetylides. Sodium acetylide. You could see the acetylene. Okay, CH triple bond CH. With acetylene, sodium reacts to give sodium acetylide. Sodium acetylide.